Hello everyone, welcome to Tutorials by Decade. My name is Decade, and in this video we are actually going to add our first enemy. With that being said, before I begin, if you haven't subscribed yet, please do so, as I have videos like this coming out all the time and I don't want you to miss anything. And as always, don't forget to thumbs up and like my video if you learned anything, if it taught you anything. Yeah, but with that out of the way, let's move on. So the very first thing we're going to do is we are going to go to our sprites. We're going to go to characters and then to enemies. And we're going to do the slime here. You can technically do this with almost any enemy on this list, but I figured the slime's kind of an iconic RPG, action RPG enemy, so we might as well start with that. So if you haven't done so already, just like with all of our other sprites, we got to change the pixels per unit to 16, filter mode to point no filter, and compression to none, and then we're going to hit apply. Then we're going to open up the sprite editor, and we're going to do our slice, grid by cell size, and these should be 16 by 16. We're going to hit slice and apply. So a lot of the first part of this video should be kind of familiar to you by now if you've been following along with the series. So I am going to go a little bit fast with some of this. So if you miss anything, I apologize, but we've covered this a few times now. So with that out of the way, let's drop our slime in there. And I like to be precise, so negative 4.5 and negative 6.5. There we go. Let's actually add a sorting layer, and we will name that sorting layer enemy. We'll put it above the player. Go back to our slime. Put the slime on the enemy layer, and we'll rename the slime while we're at it. We'll just do blue slime. And now we need to add a couple things to the slime. So for starters, we need a rigid body 2D. So rigid body 2D. Gravity scale to 0, constraints to none, interpolate to interpolate. Then we need 2 box colliders. So the first box collider is going to be our physical box collider. So all we need to do is edit it and make it roughly the same size as our little slime buddy here. There we go. That should work. Then we're going to add another box collider, and we're going to make this one a little bit bigger than the slime, something like that. This will be our hurt and damage box. So there we go. And then we also need to add an animator to our slime. All right. So now we can begin animating our slime. Wow, we want to make sure our slime is selected. We want to hit create and make sure we put this in our animations. We'll create a new folder for enemies, and inside that we'll create a new folder for blue slime. And then our first animation will be slime, B for blue, and then idle, and then down, because we're going to have an idle animation in all the different directions. So we need to get our sprite sheet for our slime back up here. And for the idle down, I think we're going to do 0 and 15, and then repeat the last one at 20. So it should look something like that. And I think that'll do pretty good there. So now we repeat it for all the directions. Now we're going to do 2 movement animations. One's going to be slow, one is going to be fast. The idea behind it is the slow animation is going to be when the slime is just wandering the map, and then the fast animation is going to be for when the slime is chasing the player. So let's do slime be slow down. Then we'll just do something like that, and then 20, and then 40. So yeah, that looks pretty good there. And we'll repeat it for all the directions. And now we're going to do literally the exact same thing, but we're going to do slime be fast down. And we're going to do half of that. So instead of 20, we'll go to 10. And then add the animation at 20. There we go. And then we're just going to do the same thing. Perfect. So now that we have all of our animations done, we can go to the animator. We can select all of those and hit delete. And then over here in parameters, we're going to do float, move X, float, move Y, bull is moving, and another bull is fast. So then we're going to create our state here, and we're going to name this one idle tree. We're going to double click on it. We're going to click on the blend tree here, and blend type, simple 2D, directional, move X, move Y. We'll add our 4 fields. And as you can see, our animation list is starting to get kind of crazy. So again, this is why I kind of harp on naming. So that way you can tell what is what, but even then, sometimes you have to type it in. So we're going to do up here in the search bar, we're going to type in slime underscore b underscore idle underscore down. And then 0, -1 for that. And then we're just going to repeat the process. Then we can go back to our base layer. And down here, we'll right click, create state from new blend tree. We'll make this one the slow tree. We'll make a transition from idle to slow, and then from slow back to idle. We'll click the transition between idle and slow, get rid of the exit time, get rid of fixed duration. And then conditions, we'll add is moving to true, but is fast to false. And then the return between slow and tree, we will also get rid of exit time and fixed duration. And we will add is moving false and is fast false. And we'll double click on slow tree, click on the blend. Again, 2D simple directional, move X, move Y, add the 4 motion fields, and then slime be slow down, 0, -1. And now we'll go back to the base layer. And somewhere to the right, we're just going to click, right click, go to create state, new blend tree, and we are going to do fast tree. Now, I don't think we've done animations where there's multiple animations and we jump from one to the other, but I don't think we've done multiple like move animations. So it's no different than anything else. What we're going to do is we're going to right click from idle tree, make a transition to fast, fast back to idle, right click from slow to fast, right click from fast to slow. So when going from idle to fast, we want to make sure that no exit time, no fixed duration. And then we add our 2 bulls, but we want them both to be true. So is moving and is fast both true. And then returning from fast to idle, we just do the same thing, only this time they're both false. And then we do the same thing from slow. We go no fixed duration, no exit time, is moving true, and is fast true. But from fast to slow, we get rid of that exit time and fixed duration. Here we do is moving true, but is fast false. And that's how we're going to set up the transitions between all these animations. And now the last thing we need to do is go into the fast tree, go to that blend tree, 2D simple directional, move X, move Y, and add our 4 motion fields. And we're going to do slime be fast down 0, -1. And now we have our blend tree set up for our animations. And now we can get into the meat and potatoes of this video, which is the actual scripts. So what we're going to do is we are going to go to our script folder. We don't have any enemy folders yet, so we're going to right click, create folder, and then just do enemy. And now what we're going to do is we are going to create an enemy state script first. So create mono behavior script, do enemy state. And we're going to double click that. Now I already had my Visual Studio open, but if not, let it load. And what we're going to do is we are going to change public class to an enum. And then we're going to get rid of this here. And we're going to add all the states that our enemy can possibly be in. Now again, this isn't set in stone, so later down the road, if you're developing your game and you realize, hey, you needed to add one, you can always do that. But what we're going to do for now is idle, roaming, chasing, attacking, stunned, and dead. And that is all we need to do for this. So we'll let that load. And now we're going to create a BaseEnemy script. Just like what we did with the base NPCs, we're going to do the same thing with enemies. We are going to inherit from them. So we are going to create mono behavior script, and we're just going to name that BaseEnemy. And let Unity do its thing. And we are going to open up that BaseEnemy. So in our BaseEnemy script, we're going to put anything and everything that all of our enemies are going to use. The first thing we're going to do, though, is we are going to require a couple things. We are going to require a component type of rigid body 2D. And then we're also going to require an animator. Don't know why it didn't give me that one right off the bat, but whatever. Now we can start adding some variables in here. So we're going to do header, enemy info, and for now, all we're going to have in here is the name of the enemy. We're going to serialize that field, and then we're going to do a protected string enemy name. We're going to just default that for now to enemy. Then we're going to move on to the next one, and we're going to do header stats. And then we're going to do a tooltip here, and the maximum health of the enemy. Now, before I get too crazy with this, this video we are not going to work on an actual health system. We're going to kind of get the beginnings of one in this video, but in the next video we're going to actually add damage to both the player and the enemy. So just as a heads up, but while we're here, we might as well add the stuff now so we're prepared for next video. Anyway, we're going to serialize the field, and we're going to do a protected int max health, and we're going to default that to 1 for right now. Then we're going to do tooltip, and then the current health of the enemy. Then we're going to serialize that field, and then protected int current health. Now we're going to do some movement stuff. I don't know why I keep wanting to add a parentheses at the end of that. But anyway, tooltip, move speed of the enemy. Now, depending on what you plan on doing, some enemies might not move at all. So that's why I'm going to put here in parentheses, set to 0 if the enemy doesn't move. Then serialize that field, and then protected float move speed. For now, we're going to default that to 1.5f. But again, if your enemy does not move at all, then you want to set that to 0. We're going to deal with chasing here in just 1 second, but if your enemy is chasing and you want them to move at the same speed, then you're just going to set this next variable to the same speed as your move speed. Which, let's get that in there. So tooltip, chase speed of the enemy, and then I'll put in parentheses here, set to same speed as move speed if enemy doesn't move faster when chasing. And then we're going to serialize that field. Again, another protected float, and then chase speed. We're going to default that one to 3f for right now. Now we're going to do another header. We're going to do detection. So this will be detecting the player. So tooltip, how close the player has to be before the enemy starts, before the enemy detects the player. And then we're going to just serialize that field and protected float detection range. And for now, we're going to default that to 4f. And then tooltip, how far the player has to be before the enemy stops detecting the player. Then serialize that one, and then protected float lose range. And then we're going to default that to 6f. And then lastly, for this part anyway, the player, because the enemy is going to need to know who the player actually is. So protected, transform, and then player. Then down here, we're going to put a header, enemy state, and then tooltip, the current state of the enemy. Serialize that field and protected enemy state current state equals enemy state dot idle. And then down here, we're going to do a couple things that don't need to be serialized, so we're not going to do anything crazy, but protected rigid body 2D. And we'll just do RB, make it nice and simple. Protected animator anim, and then protected bull is alive, not a line, and that is true. Alright, now we can actually get to some coding. So again, this is just the base enemy. This is what all enemies are going to have. So we're going to do a protected. What did I do wrong there? Protected virtual void awake. And in here, we're going to get our rigid body. So rigid body.get component, rigid body 2D. We're also going to get our anim. Figure that out real fast. And we already did this, but just as a safety precaution, we're going to do rb.gravity scale to 0f. rb.freeze rotation equals true. And rb.interpolation equals rigid body interpolation 2D dot interpolate. Now that that's done, we're going to go to protected. Man, I cannot type. Protected virtual void start. And here we are going to do our current health, and we're going to set that to max health. And if we forget to drop the player in the inspector, we're going to do something here. Auto find player by tag if not assigned. So we're going to make sure that we have a player assigned so that way the enemy knows who to chase. So if the player is null, meaning that we didn't add one, then what we're going to do is we're going to make a temporary variable here, call it found. So game object found. Then we're going to do game object dot find with tag, and then we're going to do player. And then if found not null, meaning we found a player, then player equals found dot transform. So that's just a little safety precaution in case we forget to add the player in there. All right, so now we need to do a protected virtual void update. And in here, we're going to do is not, or if not is alive, meaning if the enemy is dead, then we're just going to return and do absolutely nothing. Otherwise, we're going to handle state. Now, we haven't created that yet, so you're going to get an error, but we're going to create that right now. So protected virtual void handle state. And we've done a switch before, so this should be nothing new to you. So switch current state. And in here, we're going to put all of our states. So case enemy state dot idle. We're going to handle idle. And it's going to give you an error here, but that's okay. We're going to break that. I'm going to do case enemy state dot roaming. And then we're going to handle roaming. Again, it's going to give you another error. We're going to fix all of these errors here soon. So case enemy state dot chasing, handle chasing. Oh, forgot our little break there. Case enemy state dot attacking, handle attacking, break case enemy state stunned, handle stunned, break, and then case enemy state dot dead, and then we'll do handle death, and then break. And that should be all of our switch statements. And again, we have these errors, but we're going to fix those right now, actually. So let's do protected. Wow, what is going on here? Protected virtual void handle idle. So all of these handle states, like handle idle, handle roaming, so on and so forth, these are some stuff that we're going to want all of our enemies to do. So I'm just going to do handle idle, and then I'm going to kind of put placeholders in the rest because we haven't really got that far yet. But for handle idle, what we want to do is we want our rigid body, linear velocity. And by the way, if you type in linear velocity and you get an error, then you just put in velocity. It depends on what version of Unity you're using. It also depends on what version of Visual Studio that you're using. So I've had some comments on that in the past. I just wanted to clarify that right now. Linear velocity and velocity are the same thing. It's just different on whatever version you're using. For my version, it's linear velocity. And if you have all the exact same stuff I do, it'll be linear velocity for you. If not, then it'll just be velocity. But anyway, rb.linearVelocity equals vector2.0. So we want to make sure we're not moving when we're in idle. And then our anim, we're going to set the bowl is moving to false. And then we're going to set the other bowl is fast also to false. And then down here, anything else you want all of your enemies to do. Otherwise, override this in individual scripts. And we are just going to get rid of our errors real fast. So protected, virtual void, handle roaming. And to be handled by individual enemy scripts. And that'll get rid of that error. And we're going to do the same essentially for everything right now. So protected, virtual, void, handle, attacking. And I'm just going to literally copy this and paste it so that way I don't have to keep typing that out. Protected. And then it already kind of figures out what I'm doing here. So we're just going to do that. I feel like I missed one. Let's see. We got roaming. Chasing. We need to put chasing here. Protected, virtual, void, handle, chasing. And then after stunned, we have death. So protected, virtual, void, handle, death. All right. So again, anything that you want all of your enemies to do, you're going to put in all of these. Right now, we're just worried about our enemy moving. So we're just kind of putting placeholders there. But now we need to be able to change states. So we're going to do a public virtual void change state, and then enemy state new state. So in here, if current state equals new state, then we're just going to return. Otherwise, our current state is going to equal the new state. That's all we need to do for that. Now, in here, this is going to be the beginnings of our health system. Again, we're not doing anything with this yet, but public virtual void take damage int amount. And then if not is alive, meaning that we're already dead, then we're just going to return because there's no damage to take. Else our current health, no, let's try that again. Current health is going to minus equal amount. Then we're going to check if we died. So if current health is less than or equal to 0, then as a safety, we're going to set current health to 0, and then we're going to die. And we'll fix that here right now. So we're going to do a protected virtual void die. And then is alive equals false. rb.linear velocity equals vector2 dot 0. So if we were moving, we're not anymore. In here is also where you're going to put your future death animation, any loot, and anything like that. But for now, just disable the game object. So that's all we're going to do now is just disable that game object. So game object dot set active false, and then change state to enemy state dot dead. And since we're handling most of the death stuff right here, you may not even put anything in handle death, but we have it in there just in case, because some enemies, like special enemies or bosses, you may want to do something different or special. So that is why that's there. So that is all for our base enemy. Give me 1 second. Let me check the time of my thing. I'm going a little bit over, but whatever. We'll keep going because there's no point in stopping this here. So let us create, or go back to Unity. Let Unity do its thing. Let us go to create, and then folder, and then here's where we're going to put our first enemy. We'll just put SlimeEnemy. And in here, we're going to right click, create mono behavior script, and we're going to call this SlimeEnemy. Let Unity compile it. And then we're going to open it up. So I'm probably going to fast forward through a lot of the beginning of this, seeing how we've done that before to save on time. Otherwise, if this is going longer than I planned or that you anticipated, I apologize, but I can't really find a good stopping point until we get this done. So I'm going to get it done. So with our SlimeEnemy, first things first, we want to make sure that we are inheriting from our BaseEnemy. And then there's a few things that we need to do here. So we need to do a header, roaming, settings, and then tooltip, the minimum time the slime waits and idle before moving again. And then we're going to serialize the field, and then private float min idle time. For now, we're going to default that to half a second. And then tooltip, the maximum time the slime waits idle before moving again. And then serialize that field, private float max idle time, and we're going to set that to F. And then another tooltip, the minimum time the slime moves in one direction. Serialize that field, private float min move time. We'll default that to 1 second. And then tooltip, the maximum time the slime moves in one direction. And then serialize that field, private float max move time, and we'll default that to 3 seconds. Now we want to be able to bind our enemies so they stay in one spot. Now we can bind them to the entire room, or we can bind them to a specific area. And that is what this is going to be here. So we're going to do header, room, area, and then tooltip, bounds the slime should stay in. Or not bounds. Bound the slime should stay in. And then such as the room collider. We're going to serialize that field. We'll do private, collider 2D, and then roam bounds. And then two more that we need that we don't need to serialize, so we'll just do private, vector2, move direction, and then private, float, state timer. All right. So now that we have those, we can actually start working on getting our slime moving. So first things first, we're going to do a protected override void start. We do need our base start in there, but we also need to check the room bounds. So if, or the roam bounds, I should say, if roam bounds equals null, then we're going to throw a quick little debug warning here. What we're going to do here is, maybe what we're going to do, jeez, come on, fingers type, name, no roam bounds assigned, slime will roam freely. Now, that is actually going to be a bad thing, because if the slime is able to roam freely, the slime may actually exit the room, and we do not want that. So we want to make sure we always have a bound. And then down here, what we need to do is start idle. And that's going to give you an error, but we're actually going to create start idle right here. So we're going to do private void start idle. And what we're going to do first is change our state to enemy state.idle, which we should be in the very first time that the slime's loaded up. But after that, since we're going to be going back and forth, we want to change our state to idle. And then what we're going to do is we're going to do our state timer. And it's going to equal a random dot range. And it's going to be between the min idle time and the max idle time, which Visual Studio figured out that's what I wanted to do. So I just hit tab a couple times and there it is. And then what we're going to do is we're going to make sure our linear velocity is vector2.0 to make sure that we are not moving. Then we're going to set our anims. So set bool is moving false. And anim.set bool is fast. False. Now, even though we're already doing this in our handle idle in our BaseEnemy here, right here, even though we're already doing this, I still want to do this here just as a precaution. So now we want to do a private void start roaming. So essentially we're going to do the same thing, only we're doing it for roaming. So change state, enemy state dot roaming, state timer is going to equal random dot range min move time and then max move time. Move direction is going to get random direction. Now that's going to give us an error here, but we will be fixing that a little bit later. Set anim direction is going to be move direction. So again, we're going to get an error, but we were going to fix that in a little bit. And then we want anim.set bool is moving true, and anim.set bool is fast to false. And that's all we need for that. So now we need to override a couple things from the base. So we're going to do a protected override void handle idle. And I don't know why I didn't put our base in here, but we're going to do base dot handle idle. Why I put that space in there, I don't know, but there we go. So we want our base, but we also want our state timer to minus equal time dot delta time. So that way it actually counts down. And then if our state timer is less than or equal to 0f, then we want to switch to start roaming. That way, after we're done idling, we'll go right to roaming. So now we need to override our handle roaming. Now, I put the base in there for that one, even though there is no base, so we'll just delete the base because we don't need that. And then if not is alive, then we're just going to return. So again, we're just putting this check in here to see if we're alive. Anyway, we're going to do essentially the same thing that we did with idle, but for moving. So state timer minus equals time dot delta time. But now we need to actually move the enemy. So vector, we're going to create a temporary here. Vector2 velocity equals move direction times move speed. And then rb.linear velocity, or just velocity depending on which version you're using, is going to equal velocity. And then bool is moving equals velocity dot square magnitude greater than 0.1231. There we go. So that's going to change to true if we're moving, false if we're not. And then anim dot set bool is moving, and then anim dot set bool is fast, false. So you might be asking yourself, why am I setting the set bools twice? Once up here for start roaming, and then once down here in actual roaming. Well, if for whatever reason things get crazy or out of control, or if our random move for whatever reason, what we're going to do here in a little bit, doesn't pick a direction, we want to set this bool to whatever it is that we're moving. That way, if this is set to true, but we end up not moving, this will fix that. That's essentially all we're doing, is just putting a check in here. So down here, if is moving, then we are going to set anim direction to velocity. Again, we're going to get an error here because we haven't done that yet. And then what we're going to do is we're going to check if we're in bounds or not. So if we're about to leave the roam area, bounce back. So if roam bounds is not null, meaning we have a roam bounds, what we're going to do is another vector2 temporary thing here. So vector2 next position equals vector2 transform dot position plus velocity times time dot delta time. And then if not roam bounds dot overlap point, I hit a button I shouldn't have. There we go. Next POS. So essentially we're going to check to see if we're going to be heading out of our bounds. And if we are, we're just going to do a simple bounce by flipping our direction. So move direction is going to equal negative move direction. And then we're going to set anim direction to the move direction. And still a few more things that we need to do here. So if state timer is less than or equal to 0f, then we're going to start idle. That way, whenever we're done moving, we're back to our idle state. That's all we need to do for that. Now let's fix our few errors, and then we can get our slime moving. So private vector2 get random direction. Vector2 direction equals random dot inside unit circle dot normalize. So what we're doing here is we're picking a random direction between 0 and 360. Or is it 0 and 359? I can't quite remember. But nonetheless, we're picking a random direction from a circle. And then if direction dot square magnitude is less than 0.01f, then we're just going to go right. And that's just a safety precaution in case we're less than 0. That way it doesn't get confused. And then what we're going to do here is return direction. So anytime you have like a private and then like a vector2 or an int or a bool, you have to return whatever that is. So here we did a vector2. So we wanted to do a vector2 return, so that's our direction. But any other time when we do a void, there's nothing to return. So like actually here we're going to do a private void set anim direction. Now, void means we're not returning anything. But if we put something in parentheses over here, then that means we need something from something. So our set anim direction, if direction dot square magnitude is less than 0.0001f, then we are just going to return because we are not moving and it doesn't matter. And now we're going to snap to the cardinal direction. And we're going to do vector2 anim direction. And then if mathf.abs direction x is greater than or equal to mathf.abs direction y, then our anim direction is new vector2 mathf.sign direction x, and then 0f. Else anim direction equals new vector2 0f mathf.sign direction y. And that's giving me that error because I forgot to put the comma in there. There we go. And now what we're going to do down here is anim.setFloat move x anim direction.x, and then anim.setFloat move y anim direction.y. So what we're doing here is we are checking Sorry, I had to move here. But what we're doing here is we are checking to see if our X value is greater than our Y value. And if it is, then we are setting our Y value to 0, but mathf sign direction X is essentially setting the X direction to positive or -1. And then doing the same down here, but with the Y. And then we're sending that information to our animator so that way our slime can animate. Now that we've done that, we no longer have any errors in here, and we don't have any errors over here in BaseEnemy. So now we can save it by Control S or Command S, and then we'll go to Unity, let it compile everything. Then we're clicking on the blue slime. Hold on 1 second. Okay. Clicking on the blue slime, then add component, and we'll do SlimeEnemy. And all the stuff that we did is all right there. So we are going to go grab our player and drag that to here. And remember, if we forget to do that, our code will do it for us. But what our code will not do is get our collider. So what we're going to do is we're just going to bring in the room collider. This should be room 00. And we'll drop that in there. That way it confines the slime to the room. And if you wanted to, you can create, like, let's just say you wanted the slime to stay like within the pot and these two rocks here. You could actually create your own bounds using a Collider 2D. Make sure you set it to trigger, and then drop or create that, and then drop it into the bounds. But for now, I'm just going to use the whole room, and everything should be good. So let's hit play and let's see our slime moving around. Now again, slime can't hurt us. We can't hurt the slime. Slime won't chase us yet, but there goes our slime moving. Idled there for a split second. Idled there for a split second. And there we go. So our slime is moving around and doing what it's supposed to do. Now in next video, I will add our health system so that way the slime can attack us and we can attack the slime. And then I'm also going to add at some point the slime chasing the player. So if you liked this video and it was helpful for you, make sure you give it the big old thumbs up. Please don't forget to subscribe, as I have videos like this coming out all the time and I do not want you to miss anything. Plus it helps me out, so I do appreciate that. But with all of that out of the way, I'm going to end the video here. So as always, thank you. Have a good one. And I'll see you in the next video.